d by dx of 4 minus 3x to the fifth to the ninth times the square root of the same term, 4 minus 3x to the fifth. Well, now what we do is, notice this is to the ninth power. We raise entity to the ninth power times entity to the half power. Now 9 plus 1 half is 9 and a half, but 9 and a half is 19 halves. So that's how I got this 19 halves here. And then you just execute the derivative using the chain rule. And again, that's kind of messy, so let me scoot this down here. Correct, but badly spaced. So let me just do that. Now, remember by the chain rule, you replace 4 minus 3x to the fifth with u. So you do d by du of u to the 19 halves times d by dx of the interior 4 minus 3x to the fifth. Again, that's that same the x part, that d by dx just gives you the negative 15x x to the fourth. And then remember, 19 halves comes down, subtract 1 from 19 halves, and you get 17 halves up here. And then, now guys, multiply 19 times negative 15 and you'll get negative 285, and then that 2 is on the bottom. And then you have, now it's true. And we have the x to the fourth, and we have, and I need to scoot that down. That's horrible spacing. Let me scoot that down real quick. Excuse me while I get this scooted down. So yeah, it's true that we would have 19 halves times u, we would have neg 285 over 2 times u to the 17 halves times x to the fourth. But what I did was, I remember 17 halves, guys, that's 8.5. So by the law of exponents, I can go the other way and break these up. U to the 8 and 1/2 power, that's u to the 8th times u to the half. I broke it up. And then, so what that's going to allow me to do is, well, that's just u to the 8th times the square root of u. Now, remember, u is 4 minus 3x to the fifth, so what I'm going to do by commutativity, I'm just going to go ahead and bring this x to the fourth out in front. And I don't even really particularly need this times sign right here. You can keep it if you want to, but I don't. And let me space. Again, my spacing is quite terrible. So let's get that straightened up. So we have this guy right here, and we replace our u back with 4 minus 3x to the fifth with parentheses as needed. So u to the 8th is parentheses. Oops, that's not 40, that's a 4. There's a syntax error. No, they haunt me. So that's 4 minus 3x to the fifth, quantity to the 8th, and then times the square root of that quantity. Because again, that's just we had that square root of u, and u is this guy right here. Okay, so we just substitute these back in. And I think we get the idea when it comes to these type of problems. And I'll leave it for you to do this one right here on your own. And then, yeah, we can, in a similar fashion, we can do like the 7th root. Now, guys, be careful. Remember, this is understood, the 4 minus 3x to the fifth in and of himself, there's an understood 1 right here. And 1 can be thought of as 7/7. And why do we want to write 1 as 7/7? Because there's a 1/7 right here. And by the law of exponents, we can add 7/7 to 1/7 and get 8/7 right here. So we've not even executed the derivative yet. We're just doing algebra. So we got d by dx of entity to the 7/7 times the same entity to the 1/7. So that's entity to the 8/7. You just add the exponents here and here to get 8/7. And notice we've not even executed the derivative yet. So now to do that derivative, we're going to need the chain rule. We're going to let u equal 4 minus 3x to the fifth. So we do the chain rule. So we do d by du of u to the 8/7 times d by dx of the interior, or namely of the u itself right here. This right here can be thought of as d by dx of u, as always. And then now, remember the 8/7 comes down in front, so it's 8/7 times u to the 1/7. Again, if you subtract 1 off 8/7 right here, you get 1/7 right here, and the original 8/7 comes down. So we're executing we really started executing the derivative here, but then we execute it for good here. Here's the chain rule, and then once you do the chain rule, you go in and do the power rule, and you get this guy here and this guy here. Now that would be, that's negative 120, guys. Oops. and I forgot to change that. So I made another copy and paste error. So it's negative 120. Everything else is good though. Again, there's my x to the 4th, and u to the 1/7 is the 7th root of u. That's good. So sorry about that. I need to change these 45s into 120s. And yeah, and I need to change these 2s into 7s. Yikes. Oh, I'm all over the place now. So sorry, these 2s need to be 7s. Sorry about that, guys. So that needs to be a 7 down here. And 120 over 7, it won't reduce any. We can make it a mixed number, but that's not really time well spent. So there's that. And it won't reduce, though. So we get negative 120 over 4, x to the 4th times the 7th root of u. Again, just multiplying this 8 here by this negative 15 here, and getting this negative 120. And then by commutativity, I can bring this x to the 4th up in front. It was here, now it's here in front of the term. And to be frank, you can keep this times sign right, no. You can keep this times sign right here, but you don't have to keep it. You can just do that. You really don't need this one, but remember what I was telling you in previous videos, Microsoft Word makes these two jumbled together, so I'm going to keep this times sign here out of neatness, not really out of mathematical necessity. So we have this guy right here, and then so we have negative 120 over 7 times x to the 4th times the 7th root of this guy right here. And again, you can decide whether you want to keep this guy or not. And I guess you could get rid of this guy just so you can read this, okay? Well, you can get rid of this guy as long as you can read this. Indeed, you can. And but you just replace u with 4 minus 3x to the 5th here, and that's that for that. And we're really done. My clicker, it's just not as good. Sometimes they make too many of these little pop-up things, and it runs it. Makes my life harder. You see why I like to have a time sign? See how messy this right here is? You see, you can appreciate why I want to have a time sign right there. So let me do that. And I'll leave it for you to do this one on your own right here, like that. So there's that. Now let's do a different kind of problem. It's time to move on, I think. Let's do d by dx of 1 over the 6th root of x. At first that looks tricky, but remember that's d by dx of x to the negative 1/6 power. The 1/6 power is just the 6th root. The negative sign is what brings you down here, okay? Now, so we do d by dx of this guy right here. Now remember, the negative 1/6 jumps out in front, and we subtract 1 off negative 1/6. That's going to send you down to negative 7/6, right? Because negative 1/6 minus 6/6 is negative 7/6 right here. So there's that. Now, if all your professor wants is the power, really, in a way, we're done. We've already executed the derivative. So this guy right here is really, calculus-wise, we're done. Algebra-wise, it depends on what your professor wants. So if your professor insists on having radicals and rationalized denominators both, well, if he or she wants radicals, you could stop here in this step here. But I got a feeling he or she might want you to rationalize. And now, well, I need to skip a line there. So we have that right there. Now, now guys, that negative 1/6, we multiply it. Now what we need to do is, notice that x to the 7/6, that's x to the 6/6 times x to the 1/6. And the reason, that's by the law of exponents, and notice that 6/6 is 1, so this is x to the 1 power. So that's just negative 1/6 times 1 over x times x to the 1/6, where the 1 power right here is understood. Now guys, what I'm going to do next is a little tricky, a little slick. I'm going to stick an x to the 5/6 down here, because I know that this 1/6 will add to this 5/6 and give me another x to the 6/6, which is x to the 1. But now, notice I did stick this down here artificially, so what I've got to do is stick another x to the 5/6 up here to consolate for the fact that I stuck one down here. So I have negative 1/6 times this guy right here, and let me skip a line. And so what I have, so it's negative 1/6 times. Now guys, remember by definition, x to the 5/6 power, that's the 6th root of x to the 5th. That's by this right here. The 6th root of x to the 5th is the very definition of x to the 5/6 power. Okay, now down here, by associativity, I can go ahead and multiply x to the 1/6 times x to the 5/6. and that's the way I want it to go. And remember, by the law of exponents, I add the 1 6 and 5 6 and I get 1, because 6 6 is 1. So it's just another x to the 1 power right here. So I have x times x to the 1 times x to the 1. So that's just x squared down there, and the same old guy up here. And really, we're done. You can stop here, or now this is just, your professor will, I'm sure, will be fine with either of these. You can stop here, or you can do it like this, where the 1 is understood to be up here, and the 6 is directly down here. You can bring the 6 and the x squared together down here. You can bring the 1 and the 6 root multiplicatively together. Now 1 times the numerator is just the numerator himself. So there's that. You can stop here if you want to, but or if you prefer this, either way, just whichever one you had prefer. Okay, so there's that. And let's look at something else. Let's look at this one now. Now I'm gonna leave it for you to do d by dx of 1 over the 7th root of x. Guys, this video's been fairly heavy going. Let's stop the video there, and I'll see you on the next video. Bye bye.